If you grew up anything like me, when you were a kid, you probably had the three R's drilled into your head, those standing for, if you somehow managed to get through life without hearing them, reduce, reuse, and recycle. So that's generally good life advice. It's part of the whole sustainability thing. Don't buy stuff you don't need. Don't create garbage that's going to end up in a landfill or worse, the ocean. And as it turns out, this is also pretty good advice for optimizing your code. Hello all the crazy people out there, my name is Michael, I like wizards and dragons and making games, and it has been a moment since I've made a video about specifically optimizing 3D games in GameMaker. So the reason I'm doing this now is that in the today beta, or the yesterday beta, I'm not entirely sure when this video is going to be posted. Anyway, in the most recent beta, as of this video going up, there has been an interesting new addition made to some of the matrix functions, which under some circumstances allow you to speed up the amount of time that it takes to do things like build or multiply a matrix by a considerable amount. Before I start, this is part of a long-running series that I have made on optimizing 3D games in GameMaker. If you haven't seen the earlier videos, I would recommend going and watching those before this one. They do semi-build on each other, and also in general, the first ones in the sequence are easier, the later ones are a lot more advanced. So what exactly is this change that we're talking about? So when you use one of the matrix functions in GameMaker, it will take a series of inputs, it will perform some calculations to build a 4x4 transformation matrix of one type or another based on those inputs, and it will create a new array of 16 elements, feed those values into it, and return that to you. And depending on what exactly you're doing, the act of actually allocating the array of 16 elements itself can be 50% or even more of the total amount of time that it takes to compute one of those matrix functions. And if we think back to the three R's discussed at the beginning of the video, if you were to reuse or recycle one of the existing matrices, in this context it's kind of the same thing, the metaphor doesn't work perfectly here. Then you could theoretically speed up the amount of time that it takes to do things like build a matrix or multiply a matrix by a considerable amount. And we're not talking about like 5 or 10% here. We're talking cutting the amount of time that it takes to build a matrix down by more than half. And this also works for matrix multiply, this works for matrix get, matrix build, look at matrix transform vertex, which works with an array of 4 values instead of 16. The ones that I'm going to be focused on in this video are going to be build and multiply because those are the ones that you'll probably be using most often. Technically, this optimization was added to the matrix multiply function a while ago, but I've been putting off making this video because I have been hoping that other matrix functions would get similar treatment at some point or another. And now they have, and we can celebrate. So, this chart is cool and all, although it does make this video so far look kind of like a PowerPoint slide, so I'm gonna get that off the screen. I'm going to go over to my sample project, and now we can start looking at code. So if I run the first of my sample projects here, we've got a forest of, I think about 3,000 trees is what I set it to. And they're doing decidedly like non-realistic tree things like spinning in circles and what have you. The point here is that each of these trees has a couple different matrix operations being applied before they're drawn to transform them in different ways. So let's have a look at the code that is going to do the actual drawing of these trees. That's in the draw all the stuff in the world function. If we come down to the bottom-ish, we've got the loop which loops over every tree in the world. It's going to do a few things such as build a translation matrix, build a rotation matrix, build a scale matrix. It's going to multiply them together in a specific order, and then it's going to set that as the world matrix. So this would be a good time to mention that this is a slightly stilted example. If you really wanted to make this run as fast as possible, you would probably do other things. I have made previous videos on optimizing the use of matrices in GameMaker in the past. That all still applies, but I'm kind of going to be ignoring that because I want to show the magnitude of the change that we're going to be instituting here. So before we change anything, let's have a look at the debugger so that we can see what exactly is happening performance-wise. So this is running according to the little performance meter at the top at about 50-ish FPS. If I go over to the profiler in the debugger, which if you run the game in debug mode can be found debugger windows profile down here. And if I were to say start profiling, let's get the step percent off the screen because I don't care about that. If we look at the time that it takes to actually do this, the frame time is about 20 and a half milliseconds. So again, it's running at about 50 FPS. And if we expand the heading under draw all the stuff, we can see that the matrix set function being called 3,000 times is accounting for about half that. Other things can also be found in here. So matrix build is called 9,001 times. Nice, that's accounting for about 3.5 milliseconds. Matrix multiply is being called 6,000 times. That's accounting for about 2 milliseconds. On my computer, on your computer, your mileage may vary. And we're just gonna keep those numbers in mind, and we're gonna see what happens when we start changing stuff. So I said that the main idea here is to reuse and or recycle an existing matrix instead of creating a new one every time. And if we wanted to just create outside of this for loop, so this is just going to happen once when this function is called and not 3,000 times, something like translation. And this is going to be an array of 16 elements, and you can initialize it to like matrix build identity if you want the identity matrix. You can also just initialize it to array create 16 if you just want an array of 16 values, which is really all you need because every one of the 16 values is going to be overwritten by what we're going to do here. So if you were to instead say matrix build XYZ, X rotation, Y rotation, Z rotation, X scale, Y scale, Z scale, and then there's an optional 10th argument, which is going to be the results matrix, and we can feed in that translation matrix that we created once at the beginning here, and that array is now going to have its values populated by the 16 values that you get if you did a matrix build to get one from scratch. This function will still return a value, so if you wanted to get the same like output matrix back, you're allowed to. You're allowed to just like reassign it like that. There's not really a point in doing that. If anything, if you have old code and you want to just update it to do this without having to really rewrite a lot of stuff, it might be best to just leave it. But because I think it looks weird to reassign a variable to itself, I'm going to get rid of it. And also Feather doesn't seem to like it because Feather has ideas about declaring variables twice. Anyway, we're going to do the same thing for rotation and scale. And we can give the rotation, the matrix build for the rotation component of the transform. We can give it that. And also the scale matrix can do the same thing. So this is going to, when we run this, it's going to look exactly the same. The results, the numbers are going to come out of these functions exactly the same. They're just going to be basically cached in one place instead of being recomputed from scratch every single time. And if I were to move the camera over here, I don't think I actually got the lighting calculation right on this, but that's okay because I was in a hurry and we're not interested in lighting right now. We can see that the total frame time for the camera draw event over here and drawing all these trees has now gone down to from like 20 plus milliseconds to 17 plus milliseconds. And in particular, the cost of matrix build has gone from 3.5 milliseconds to like a third of a millisecond. So that's a reduction of about 90%, which is a lot. I'm actually interested in that because that's actually more of a reduction than I thought we were going to see. And I'm not entirely sure why, so that's a bit of a mystery for now. Anyway, the actual frame rate that we're observing has gone up. FPS real has gone up from like 50-ish to like mid-50s, so this isn't the sort of thing that's going to make your game go from like 15 FPS to 60 if you're having that kind of problem, but it is the sort of thing that can possibly push you over 60 if you're just like hovering around the boundary or that kind of thing. So that's nice. If you look at the matrix multiply function is still largely the same because we haven't touched that yet, and that's what we're going to do next. So we're going to be doing two matrix multiplies here, so transform to get the rotation and scale. So we're going to combine those, and then a final transform to take the rotation and scale and combine it with translation. Matrix multiplication is kind of finicky in that you have to do it in a certain order, because matrix multiplication is non-commutative, otherwise you get weird results. If you're just doing this, strictly speaking, you can really skip a lot of this and just feed all the arguments into a single matrix build, but again, for the point of this video and for the point of showing what kind of a difference this makes, we're not going to be doing that. So I'm going to define var transform rs equals array create 16 elements, and lastly transform, I guess I'll call it transform final equals array create 16 elements like that. And our matrix multiply function can get a similar treatment to the matrix build, so there's now an optional third argument which you can use to pass in an array which will have its values populated, and we can do that twice. And lastly, matrix set, matrix world, I'm just going to need to update that variable name because the original no longer exists. And if I run the game now, we are going to see that we're not going to get another huge, what was that, like probably 6%? I mean, it would really be like 10% or so, 10 or 15% chopped off of of the original. We're not going to see anything like that, but we will see that the total frame time has gone down from 17 and change to 15 and change. We can see that the cost of those two matrix multiplies has gone down from like, what was it, 1.5 to like 1/4 of a millisecond. Again, that's actually more of a savings than I observed in just like the pure synthetic benchmark, and I'm interested in knowing why that seems to be the case. But regardless, FPS real is now like 70-ish. FPS real really isn't the most useful metric to look at here because frame time and FPS are inversely proportional, and well, it's easy to read the wrong thing out of FPS real if you don't know what you're looking at. But anyway, this has gone down from a combined like 5.5 milliseconds to like 0.5 millisecond to do all this, and that is definitely significant. Perhaps not like completely game-changing, but definitely significant. So, by the way, in my testing, I also did find that the gains from this are more significant in yo-yo compiler mode than in VM mode. I didn't like test this exact scene in yo-yo compiler. I guess I'm gonna just go and undo everything that we did here so that we can go back to the original version. We can switch the build type to YYC, and then we can run this. This is going to take a minute to compile. The debugger will not work in YYC mode. It only works in VM mode, so we can't really look at that. But we can see that, all right, at the moment, we're getting about what we had when we started in the original version. We're getting about like 50s, maybe slightly higher than that. We're not actually doing that much just like mathematical logic here, so we're not going to see that much of a boost from YYC. Whereas if I were to... Oh dear. I thought I'd copied my code so that I could just like paste it back in after that, but I don't think I did, and I'm just going to have to rewrite that from scratch. Give me 2 minutes. Alright, much better. So now let's run this in YYC, and we can see what this is going to look like. So there is another component to this, believe it or not, that's not really easily seen in benchmarks. And that is that when you allocate like 15,000 arrays or whatever, however many matrices we were creating and discarding in every step of the game, that also means that the garbage collector has to track and get rid of an additional 15,000 arrays, which is a lot. GameMaker's garbage collector is pretty good nowadays, but if you throw that much data at it that it has to comb through, it's still gonna take some time, and not giving it that much extra work for no reason is always a nice thing to be able to do. So I see here that our FPS real is about the same that it was in VM. Again, we're not seeing a huge gain here, probably mostly because the expensive parts of this are not like math functions or anything like that. At some point in this process, you have to actually set the matrix and then draw like 3,000 trees, which in and of itself is not free, but alright, I was just curious. Let's go back to VM because I don't feel like sitting there and waiting for the YYC to compile every time. What else? So, all the other matrix functions, like I mentioned, except for matrix set because that doesn't return a value, but all the matrix functions which return a value, so build identity, build lookout, projection perspective, matrix get, matrix inverse. These all now have the same ability. If you were to look at the argument list for like matrix build, projection, ortho, you can see that it now also has an optional results matrix. I'm not going to spend a lot of time thinking about these. You can do that if you want, but most of you are probably only going to call like matrix build projection once per frame, maybe like 2 or 3 times per frame if you're doing shadow mapping, maybe a couple more times than that if you're doing multiplayer split screen. But unless you're doing something really and truly bizarre, matrix build projection is not going to bottleneck the game the same way that calling matrix build over 9,000 times is going to. Matrix build identity is also going to get this treatment, so you can basically use this to... Oh, does it not? I could have swore it did. I was going to say you could basically use this to like reset a matrix to the identity matrix, but it doesn't look like it actually does, unless the optional argument is just missing from Feather. Anyway, since the identity matrix is really just literally one thing, and it's not like you can have different identity matrices based on the input parameters, what you really want to do with the identity matrix, if creating them is taking that much time, is just to like create it once and reference it as like a global variable or something like that, which will be much faster than creating a new one from scratch every time. I think that's it for like matrix manipulation, I do want to look at matrix transform vertex, which is kind of like the odd one out in this family of functions that have been modified here. So if I go back to a different one of my 3D optimization demos, this one is going to combine. Can I not have that full screen, please? Not sure what the point of that was, but this is a demo which is going to take some large number of trees, and it's going to combine them into a single vertex buffer. That is a separate optimization. That will eliminate the need to, like, multiply and set matrices together pretty much entirely. It does come with the, come at the expense of being able to, like, move individual pieces of a vertex buffer individually, at least not easily. And the way that we're going to be doing this is, this font size is really small. The way that we're going to be doing this is by iterating over each of the vertex buffers and using a function called matrix transform vertex, which is going to basically multiply a position or a normal vector by a transform matrix, and it's going to return an array of 4 values, which you can treat as like a vector 3 or a vector 4. And that's a little bit less intense than returning an array of 16 values, but it also does still have a cost, and we can look at eliminating that from the process as well. And firstly, this isn't something I can easily profile because it only happens like when the game is created, but I can time the amount of time that it takes to actually do this. Oh, it looks like I actually am already, so the time to merge the meshes is going to be 1.84 seconds. Let me actually put that in terms of milliseconds instead. It's not horrendously long. It is obviously longer than probably most players would like, given the choice. It's not perhaps quite long enough that a player would sit on the loading screen and think something's broken. Anyway, so we can come over here to where we're doing this matrix transform vertex. Let's go and say var position is going to be array create 4 elements. We can say var norm equals array create 4 elements. This is going to be a vector 4, so x, y, z, and w. This is actually something else that was added since I originally did this combining vertex buffers video, because you can now specify a w coordinate when you're doing this matrix vertex transformation, and that's much like if you were to do something in the shader and transform a position by a matrix or a normal by a matrix. So the homogeneous coordinate of w for transforming a position is going to be 1. We can take our results array. That is going to be this position value here. Let's go and get rid of that reassignment because that's silly. For the normal, we're going to want the homogeneous coordinate of w to be 0 because we basically don't want the translation to be factored in when we transform the normal because that's silly. The output array can be norm like this, and we can get rid of this because it's silly. This down here is just making sure the vector is normalized, which is what you want when you have a normal vector most of the time. I also just realized that to get around the fact that GameMaker didn't always let you transform a vertex with a homogeneous coordinate of 0, I was apparently building my own matrix, which was identical to the source one, but it had no transformation. I can actually just get rid of that now, which feels good to be able to do because that was kind of nonsense. So the original version of this took 1.84 seconds to run. Let me go and run this again, and we can see how long this takes. I suppose we can also see that this looks the same as it did before, and I believe it does. It's weird to see them not rotating, but I don't think I was having them rotate before, so that would be correct. And how long did that take? That took 1.63. So all the other stuff that has to happen when you combine vertex buffers still happens. So reading out the positions, adding them to the destination vertex buffer, that all still has to happen. And this here is only a small part of the operation, but it is there. I'm going to say that was about 10%. It is certainly statistically significant, and I think most people would gladly welcome such an improvement. So that is all I really have. That is the optimization to the matrix functions, which I think a lot of people will be happy about. I certainly will. My name is Michael. I like wizards and dragons and making games. If you want these sample projects, look for the GitHub repository down in the video description. I believe this sample project has a collection of different optimization examples, all in a single repository instead of just one. I like to post videos on weird stuff you can do in GameMaker, so if any insane 3D stuff like this appeals to you, feel free to subscribe. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. You should all go check out Wizard X and the Lost Hat, which is one of the games that I like to work on when I'm not doing YouTube stuff. Link to the Steam page can be found down below. I hope you all enjoyed that, and remember, the first R stands for reduce. As in optimizing your GameMaker games, as in life. Special thanks to Zenjamin, Squarecrow, Spy-Die Games, Pixelated Pope, Manta Ray, GameMaker, GameArt Indie, Edward Holt, DJ Gibbles, and Bokeh for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.